Next thing we're going to take a look at is angles of elevation and depression. Basically what we're going to do today is we're going to apply right triangle trigonometry. So just a couple of vocab words with angles of elevation and depression. So elevation, what this is always between is the horizontal and line of sight. So imagine like if you're standing here, so your angle of elevation is in between the horizontal and your line of sight if you're looking up. And so you have a right triangle. Whereas depression, it's the same thing with depression, but you have to think depression means that you're looking down. So it's between the horizontal and the line of sight going down. So that's the thing you always have to remember, is it's with the line, the horizontal line of sight. Because a lot of people just like to look like this and they say this is depression, but again, it's with the horizontal and looking down. So that is actually your angle of depression and not just in a triangle what's going down. So the first problem that we're going to look at, they're going to take a look at a couple word problems. From the top of a fire tower, a forest ranger sees his partner on the ground. At an angle of depression of 40 degrees. If the tower is 45 feet in height, how far is the partner from the base of the tower? So this is going to test your art skills here. So from the top of a fire tower. So we have a fire tower. So, I don't know, maybe. Here's our fire tower. So there's this person right up here. Sees his partner on the ground at an angle of depression of 40. So remember, horizontal and looking down. So here's our angle that we know is 40 degrees. If the tower is 45 in height, so if this side's 45, well, that means this part is 45. We want to know how far is the partner from the base of the tower. So how far is he from the base of the tower? So we want to know this distance. So you can see we have two right triangles, and you guys might remember from geometry, if you make a Z with parallel lines, if that side's 40, then this is also 40 degrees. So here's our right angles. So we have two triangles where we could calculate this out, because if this is x, here is x. So either one, if we use 40, this is opposite. If I was using this bottom 40 and this is adjacent. So the tan of 40 equals opposite over adjacent. So we multiply by x. X times the tan of 40 equals 45. Divide by the tan of 40. So we have x equals 45 divided by the tan of 40. And again, we can do this on decimal. So we go here, make sure click functions, trig, and I better check wrench key. Yep, we're in degrees. So functions, and I already forgot what I'm typing in, 45 divided by the tan of 40. So 45 divided by functions the tan of 40, 53.63. So we'd have 53.63 feet. All right, so let's take a look at one more here. Find the length of a shadow. Cast by a 10-foot lamppost. When the angle of elevation of the sun is 58 degrees. Okay, so we have a 10-foot lamppost. We want to find the length of the shadow, so shadow is on the ground, and the angle of elevation of the sun. So between the horizontal and looking up, so our angle of elevation is 58 degrees because it's like we have the sun, happy sun right up there. So again, if we were to set this one up, it looks like another tangent. So the tangent of 58, opposite over adjacent. So x times the tan of 58 equals 10. So we got 10 divided by the tangent of 58. So we have 6.23 feet. So this would happen to be both tangents. They're not always tangents. Just make sure you're getting everything labeled correctly, and then you'll be using those trig functions to solve.